Okay, are we here? It was every time I do this, there's like a little hiccup, and I always wonder if we're actually on. So, if I had $1 million, I'd be CastleMiner's biggest investor. I appreciate that. Have we? Somebody asked here, have we hit our protein today? We have 100% have hit our protein today. Have you guys hit your protein today? You know how to calculate your protein targets. Okay, are we on? Everybody can hear me? We're all good? We're going to jump right into this. I'm never quite convinced that it seems like something goes wrong just about every. Oh, we got a lot of people just right off the bat. Okay, cool. We started working on this last time, and I ran into problems with Unreal. You have to realize that I don't know how to use Unreal. This is like all new to me, so a lot of these times I'm learning as I go here. I've used other game engines. I've made other game engines, so like all the fundamentals are stuff that I understand, but this is all new. So it's kind of entertaining, right? Because I'm learning it just the way that somebody else would learn it. Let's get in here and explain what we're doing here. Before I do that, let me drop I'm going to drop the FAQ. This always seems to, the first thing we seem to get is a flurry of questions that we answer every time. So I'm going to drop the FAQ in the chat here, just so that if people have questions, they can do that before asking me. You're applying for the CEO of every company. You can take my job. You can take great. Okay. So I have a need in the game for objects that get hot. And I want to have a cool visual effect for that. We'll talk about that when we go to put it in the game, because I kind of want it to be a surprise. In the meantime, Diet Coke. At least that one didn't go over the all over the keyboard. So anyways, I want objects that are hot in the game. So I've been building out this effect to do this. The last time I got kind of frustrated, and I was making it harder than it was, but it was got it working. So anyways, in our little, we have a level that we call the armory that's like left over from our old games, because usually in that place you have all the weapons set up. I made a nice little sunset and drop some objects in here that we can play with this effect. If I run this level, what I get is all the, by the way, is I get all the, hopefully, blocks in our game up here. And we can check them all out just to make sure. This is a good sanity check just to make sure that everything is running well and we're not having any texture problems and stuff like that. Since the last time, we've added beveled rocks for decorative. I think I've put a beveled. We have granite will be a thing in the game. It's a different, harder rock. Beveled limestone, and that object turned on back there. We should gave away my big surprise. And I put in beveled bloodstone, which I actually thought was pretty cool. Somebody asked what the engine, the CastleMiner Z, was made originally. It was made on XNA, which isn't really an engine. It was our engine that was built on top of XNA. XNA was kind of like a core technology. Okay, so we don't need to be in this editor anymore for now. Okay, so here's the objects. Let's just fix the camera view here. I wish there was a way to dock this. This is the shader editor in Unreal. I'm just I built this out already, but I'm gonna do it again for you just so we can see how everything looks. So it turns out that there is Unreal has this curve built in for us. Let me break that out, yeah. Has this color curve in here for us. There is a color curve for how things look when things get hot. And oh wow, donations! Thank you so much. Thank you. buy yourself a Diet Coke. I will. 3 or 4, possibly. Will the mobs have pathfinding AI? It's very, very difficult to do pathfinding in a environment that you can change so dramatically, but I'm really impressed about already how our zombies can find you. It's pretty amazing. Somebody's asking what the progress is on the game. It's really hard. Like, this is just like an approximation. Like, I have to really think about what has to be done. I keep saying 40%. I don't really think that has really changed just because major stuff hasn't made it into the game yet, but there's some major stuff in the works right now. Like right now we're working on the zombie as our first enemy, and where that's in progress, and we're working on Steam integration so that we could get early alpha testers into the game. Because we need Steam integration from that. And after that, there's like networking and saving worlds has been going on, and that's kind of big things that don't show anything as you have progress, but when they're done, they're like major things in the game. So once we have Steam integration and saving worlds, then we could potentially get early alpha testers to be inside the game just to run around and build things and tell us how stuff works. And ideally what I'd like is people to build cool stuff that we could put in like the Kickstarter trailer. So anyways, let's look at this. There's this predictable color curve for how things look when they get hot. And what I'm going to do here is I'm going to hook this up to the emissive channel inside of our shader here. So that we can take a look at this color curve. So if I save this thing here, everything's going to turn up to a different color. There we go. And now I have a timer. This is actually degrees in Kelvin, which I can adjust. So I can take here and I can take the temperature of these things, and as I put them down, they turn. And this is totally not the right one. Okay. I got to find the right one. This is it. Here we go. So this is the temperature value, and as they get colder, they'll turn back into rock, but as they get hotter, they'll turn up to white hot. So this is a black body color curve, and it's cool that Unreal actually has this built into it because I spent a long time in the last stream trying to get this color curve right, because you're used to seeing it in real life. So if you get it right, it works pretty good. So you can see like things will get hot and I can cool them out, and this is like adjustable to a real temperature. So I can simulate the temperature of something in the game and how it would get hot. This is like, like the burner on your stove or a piece of iron in a forge. And the cool thing is because I've hooked this up to the emissive channel of the game, it throws light around here. Like you could see if I had this into the base color instead, like let me take this off and save it, you could see that the objects would change color, but they wouldn't light the environment up around them. So if I could do the same exact thing now and they'll just change color, but they're not lighting up and glowing like they were before. So this emissive channel is the color that throws the light off. So we're going to take the original value and put it right back into the base color, and we're gonna put the temperature back into the emissive, and just let's make sure that we got that right. Yeah, okay, so we got this, that's super hot. Let's crank this down a little bit. So the first thing that you want to do is these are super solid and they don't look very realistic because of that. So the first thing I could do is I can multiply in the AO map for the and this is me like so this is kind of what we do, right? Like we decide on a real world effect that you want to simulate. This is what the core of game development is. You decide of like a real world look that you want to get, and you figure out like what kind of fake things you can do to like sell the look, to make it look like you want it to do. So I'm going to take the AO map that we have here, and what the AO map is sort of like the objects, the shadows that are sort of internal to the object yourself. So if you had like like an object that had like deep crevices in them, there would be kind of like shadows inside the crevices. And this map is something that sets that up. And what I could do is just multiply these values together and put them here. And now I get something that is a little bit less regular. It starts looking more realistic. So you could see here, if I change the temperature here, it's this solid color, but it looks like the deeper portions. And actually what I have here is, I think it's the reverse of the AO map. So the areas that are closer to the inside of the object end up getting brighter. And because we're doing this along this curve, actually we're not, which is interesting. Wow, this is a way, I didn't even think about it. There's a way we can improve this. We're multiplying the end result of these two things, but really we should be multiplying them into the color, into the temperature itself. So let's do that instead. Let's multiply this one by this one, plug that into here, and plug this into here. That actually should give us a different look. It does not work. That's interesting. That's an interesting thing. I have to think about this. This is actually, you can see this is like, we're getting here is that some areas get hot and some don't. I didn't really want that. I wanted it to, but I wanted the gradation effect. I didn't want it to be so intense. I think it's funny. I'm going to explore this when we look at this afterwards. Like, that isn't the right way, but I want to get to where I was before, and then I'll actually take a look at this again. So let's set this up the way it was. Into here. This goes into here. This multiply goes into here. And we have this. And we can drop the temperature down. Okay, so this is kind of cool, but this is not how this ends up. This is not how this stuff ends up looking in real life. And there's a reason for this, is because the only one that's going to look here right, by the way, is the cube. The other ones are going to look screwed up. But in real life, if you were heating up this cube, what happens is that the corners of the cube and the edges end up cooling faster because they are further away from the center and they have more surface area. So we want to simulate that too. So what I can do here is I can just take the UVs of this texture and I can build a distance from the center map, basically. I'm going to just really quickly just throw this into there to show you. And what this is showing me is dark areas are close to the center, and as they get further away, they turn white. And that shows us basically it's a map of how far things are from the distance to the center. So what I could do that is use that value to attenuate the heat. So basically what I'm doing is I'm making it so that the further you get away from the center, the colder the object is. And if I save that and I put that in, you start to see this starts to look, the cube here is the one where it really pays off. It starts to look a little bit more realistic, and we can jack the temperature around in here, and you start to see that this object, and one of the reasons why this really sells it is that now instead of seeing one solid color across the face, you're seeing a gradation of the black body colors across the whole body. But one of the things I'd like to tune here, and I experimented with this before, is that I want to change that curve a little bit. So instead of just like throwing that right in, I can turn that into like a power curve and do a little math on it, and push that boundaries out to the edges. And now when I get this is like really the end of the effect here is this sort of thing where even when it's really hot, there's sort of areas on it that are cooler. But I kind of want to get the AO to, it's interesting, the AO is, that actually might be the right effect. It's knocking back the color instead of changing the color of it. So it looks like it's light that's shining through the object. Thank you so much for the donations. CMZ, but every enemy spawned is the undead dragon. I'm going to like all the comments. So this is cool. So we got this working. But the problem here that you see is that we cheated this out with the UVs, and it doesn't work on lots of different objects. It just works on cubes. And this is where I had added... Man, where did my rock go? That was the hidden object that we saw in the beginning. Oh, rock chunk. Here we go. This one we did a little math. The math is a little bit off on the edges. I'm still working on that. But this is our object here. So this is kind of where I wanted to get to. And this is a different shader. So let's pull that one up. That was the original one that I was tweaking. Yeah, this one. Yeah, so still working on kind of the edges of this, but it's pretty there. I would say like 90% of the way there. It looks like it's hot. Like you wouldn't, if you came across this thing, you wouldn't want to pick it up. At least not with your bare hands. Okay, so what I want to do now is I want to build a particle system that ejects these and they cool down as they go through the air. And that's going to be our next thing I'm going to do here. And I actually don't know how I'm going to do this. So I have somewhere on my computer here, I have a grok conversation where I've been going back and forth on it. And I was going to follow the instructions that it gave me. Maybe this one was in GPT. Yeah. And I'm going to kind of start going through the instructions for setting up this particle system. And see if we can get this to work out. And it's kind of rewarding. I try to save the cool looking stuff for the streams versus me just struggling with stuff because it's when stuff comes together is that stuff looks really good. Okay. Let's do it. So it tells me here the first thing I need to do is create a emitter as a mesh renderer. So we will go new. Why does this look totally different now? Oh no, it's in here. We do it in the content drawer. Okay, let's yeah, we'll take our shader away here. And yeah, new Niagara system, and we want a mesh renderer template for a mesh. Do we see it? Mesh, upward mesh burst. A burst of meshes spawning upward in an explosive shape. See what my options are here. Mesh renderer, multiple meshes on a single. I'm totally new to all of this, so I'm curious which one. We definitely want multiple. Let's just start with this one, and then I can learn and then do the second one, because I think that this is rock emitter. Let's call it that, and let's drop one of these in our scene. And this is, yeah, cool, cool, cool. Okay, and there's a way to play these. Yeah. No. Loop. Yeah, cool. Okay. Okay. We want. Somebody's asking about the Kickstarter launch. We want to wait till we're a little bit further done with the game before we do the Kickstarter launch. Okay, so go set the renderer to mesh renderer. In the emitter settings, it's funny, I've written a lot of these systems for games, big game engines, so I'm real familiar with how they work, but they all work a little bit different. I do a save all here, just in case we crash and lose the stream. That's funny, the mesh has changed when I did that. Where do we do this? Rock emitter. I think we probably double click this guy and bring up an editor. Yeah. Here we go. Oh, cool. And they show it here in the little window. Let's stop this. Yeah. So it's cool. I have a little scrubber I can show there. Okay. Cool, cool, cool. So in the emitter, we have to change the mesh. So let's do that. Actually, I'm wondering if we have to save a version of this rock to an asset. That would actually make sense. Should figure that out. We'll see here. Let's just get this thing working. Emitter. Mesh renderer. Here we go. Oh, here we go. Okay. Meshes. What is this? Rock. Chunk 4. Okay. Somebody said here, congratulations on the work. I know this remake will be great. I can't wait to buy it. Thank you so much. Let's, these are a little big. I wonder if there's some way to control that. And I think I'd like to take one of these out of here. Is there a setting here that I could scale them? Oh yeah, here, let's go, we can scale these. That's all. 0.1. one. We're still getting the confetti. It's probably a little too small. 4. Too big still. Half that size. Let's just start with that. Okay. Now we have to figure out why the why we're not getting the right material. Oh, explicit material. Here we go. Override materials. So this will be, what was it? What do I call black body? Instance 2. There we go. Wow, this is a lot easier than I thought. And since we have this other set of rocks, how do I just remove this? Delete. There we go. Okay. Now we got our rocks coming out of here. Cool. That's like we're halfway there. Now, what it says to do is we want to have a dynamic material. What I actually would love to do is get these, well, we'll do one thing at a time. I'd like them to bounce around. Let's see. Add a collision module. This is interesting to do this. When I do all these things, I always kind of wish that I had more time to just really drill down on things. Let's click plus. No. In the particle update section, we add a collision. Collision seam depth or collision. Cool. Now they are bouncing along the floor. And we could tweak that to get that more realistic, but let's the temperature parameter is the one that I want to get set in there. Okay. So let's get our material set up. Connect in the mesh renderer. Let's do a save all. I'm always afraid that Unreal tends to crash and lose everything. Dynamic we have to add a dynamic material parameter. So where do we do this? We're going to ask GPT about it. Open the material. Okay, so what we're going to do here, let's start with the material. In our material, which is this one. So we're going to have those turned into boxes. This is the one we're dealing with right now. And you can see this one, we get the value from a map here. This stuff isn't needed. And let's see. It says to get rid of our scalar parameter and change it to a dynamic parameter. Okay, scalar parameter, temperatures, so replace it with a dynamic parameter. Let's see what I've never used any of this before. Parameter names, let's call this temperature, I can never spell this, temperature. And we will change the temperature into here. Let's just see how that works. Save this. This thing should get totally screwed up now until we hook it back up. Yeah, so the temperature is 0, so they're all coming out as rocks. And now let's go back to our rock emitter. And we add a float parameter to the particles. Add a float variable to hold the temperature. Go to the particle spawn section. It is so great to have AI help you with this stuff. It makes it so much easier. Add a set variable module. So add a particle spawn. We're going to make a set variable. Set a new or existing parameter directly. Okay. Use the add button. Float. How do we name this? Now I want to get rid of it. What do I do? Rename. Oh, okay. Okay. Add set temperature to the particle update. Didn't we just do that? Oh, I see. And in the mesh renderer, we go to add, scroll to the bottom of dynamic material parameters. It's funny, if somebody really knew how to do this, it would be so embarrassing. Okay. To the material section. Oh, use binding material. No. Yeah, this is it. Going back and forth with the AI, trying to figure out. Looks like I didn't create the particle, the variable correctly. In the emitter, do you see parameters? Of user This is me learning as we go. Oh, parameters. Here we go. This is where we're supposed to do it. Particle attributes. Oh, okay, so I have the wrong material. It's the base material. Okay, no problem. There we go. Add a dynamic parameter. Do we have... Okay. Let's just save all. Is this still looking right? Yep, it is. And Now in the dynamic material binding, do this. Add a new entry. Material parameters. Oh, there we go. Attribute binding. Binding. Material parameter. Nope. Dynamic material. Oh god, this is so frustrating. Material random binding, custom sorting, normalized age. I'm totally going to get this working. Capital. Somebody, is somebody commenting about the ominous sounds in the background? Yeah, I'm coding from hell right now. Okay. Okay, I think the AI doesn't know what it's doing, so let me, I'm going to have to go through a tutorial here. Dynamic parameter real engine. wonder if I should have done it here. Set a new or existing parameter directly. Add a parameter using the add button. Temperature. Wonder if that actually might be the problem. Okay. You know, the thing that sucks about a game engine is that if you didn't write the game engine, everything is sort of like new and unintuitive. Like, it's actually easier on some level to make the systems than it is to like figure out how somebody else's system works. But I guess the flip side of it is once you do, you can do things really easily. Let's go back to our mesh renderer. Everything has different controls. Okay. That does not work. Okay. There's a little... I didn't think this was going to be the place that I ran into problems. So here I am on YouTube streaming, watching a, how long is this? It's like a 30-second video on this. Well, I mean, I guess we could all watch it together. Let's see. Let's watch an ad for Adobe as we do it. See what we're doing wrong.
Hello and welcome to the Game Dev Outpost. In this video, we'll be talking about Niagara dynamic material parameters. So the quick gist of this is that there are special nodes that will help.
So this is funny. These days you end up doing this a lot in game development.
Your materials.
I actually don't know if this is going to get me in trouble with a...
So I'm going to right click, I'm going to make text, and I'm going to make a Niagara emitter. And I'm going to make this from the upward burst mesh.
This is going to get me like a content ID problem or something. Man, I don't know. I'm worried about like I'm worried about YouTube copyright things now because I'm playing a YouTube video while I'm doing. I guess this is like a commentary video. This would be like the same thing as a commentary. I'm sure this guy would appreciate this. So I don't get the sound on here. This also looks old. Okay, he's creating the material here. Oh, I get this. So each one of these parameters in the material corresponds to something inside of the Niagara engine. So we are, in our shader, we're putting in a dynamic parameter, which we name temperature, which should be fine. Can this overdrive to like 1,000? Yeah, okay. Okay, so that makes sense. So there's 4 of these that we can use for different stuff inside the particle system. That actually is the first thing that makes sense. Okay, so I'm watching this guy do this. He's wiring this all up now. Yeah, we did this already. We did this. what we just did. Okay, let's figure out what we did wrong. We're like 90% of the way there. That's probably a good idea too. Yeah, okay, I did my shader, yeah, blah, blah, blah. Okay. Yeah, where's the plus? That's what we did wrong. Okay, that's the first part that we did wrong. Okay, so we needed to dynamic material parameters. Yeah. Okay, let's get rid of these. There we go, temperature, that makes sense. Okay, that was the mistake. And particle update is, we have to do the same thing. Dynamic material parameters. Okay. This was probably in the instructions and I followed them wrong. That was super helpful. Thank you to, a shout out to who was this game dev outpost. Actually, let's finish the video and see what he has there. Yeah. Yeah, okay, totally makes sense. It's a cool thing to learn this. Yeah. Okay, so he's saying that we can just change the value in here to yeah. So you can see here is now this thing is driving the temperature of these things. So what I want him to do is start randomly and then move during the period of time. So I'm kind of curious to see how we do that. I think we just missed it. Oh, okay, we can put a curve in there. Okay, cool. Yeah, so we can do this, and we can say a curve. Now I can drive the curve. Float from curve. Let's try that. And this first value, we're going to edit this value. And we're going to make it be very, very high. Is there a way to... Because our temperatures are very high. So... like even higher, 2000 degrees. Yeah, white hot. Here we go. See this changing in the background. That's what I'm looking at. And I'm assuming this is the life of the part. I don't know any of this stuff. I'm just totally learning this as I go here. 5,000 degrees higher, hotter. Let's go. Yeah, 5,000 degrees. And in the life of the particle, let's make another one. Can I just add another node to this? Yeah, where's the other value? I don't know how to use the curve editor in the... I want to add like a another value to this curve. How do I do it? Select all keys? No? Add key, here we go. There we go. And during the life of this, we're gonna probably bring it down. It's not enough, maybe? I think maybe I should have made this shader work different. Like the reality of it is I want this thing to happen in over like a second. Yeah. So this is the problem. We got two keys that are like yeah, this is ridiculous. Let's change this shader so it's easier to use. Code count today, Jesus Christ, it's got to be like 10. At least 10 today so far. If conservative end. I mean, I drank 3 Cokes before I got to the gym this morning at 9 o'clock. Okay, this is ridiculous to drive this huge temperature value, and we don't really care about real temperature in the game. So let's start by just normalizing this from 0 to 1. So what I'm going to do here is I'm going to go to our cube here and let's see what temperatures. That 0 is obviously the low temperature. No. This one. 0 is the low temperature, and what's the highest we'll go is like 5,000 degrees down to 0. Okay, so what I'm going to do here is I'm just going to normalize that in our other shader so that's not so ridiculous. So when we go into the temperature, how do I do this? This is just a multiply, so this could be a lerp in here. So let's just, let's add a lerp node, which is a linear interpolation from 0 to 5,000, and the alpha value is our temperature. So now our temperature is normalized from 0 to 1. We put that in there. Let's save this thing. Our particle effect is going to look insane now. It's like hotter than the sun. So we can change that back, go back to our rock emitter. This parameter value now, can we just reset this curve, please? Reset. Yeah, there we go. So now we're going from 1 to 0 over a time period. It's actually pretty cool. I could spend a couple hours on this making this look really cool. Like, for example, the bigger rocks should cool slower than the smaller rocks should. That's probably an easy thing to do. Yeah, I'm complaining about our other one here. Let's just roll the temperature back down of these other objects. And they kick light around, which is cool. Yeah, that's like, we're like halfway there at least with that. Okay, I want to add some randomness to this. So we're going to learn more about, let's save everything. We're going to learn more about the particle system here. Okay, let's go back. This is a good question for the AI. Let's go ask this. Okay. just go here. You know what I'll do is I'll bring, this will be more interesting to watch since we did that. This is the hard part. Bring Grok up and I'll say we are making a particle system in Unreal 5. I have a dynamic parameter that I would like to start with a random starting value and then have it decay over time. And let's just really quick put a screenshot of that in there. Assign a random starting value. Use the initial velocity or initial parameter settings in Niagara as shown in your screenshot. Okay, so in the starting section, we want to add a, I get it, I totally get it, initial parameter random range float. .75 to 1. And let's see what that does. And we want to get rid of, let's get rid of the other one. We're going to probably do this in a different way anyways. So reset, yeah. Is there a way to just turn these off? Let's turn that off. Let's try 0 to 1. Okay, here we go. So this is giving us variety of 0 to 1. So we at least want to start at 0.25 and probably, and I don't like the distribution of that. 0.5. To make the value decay, you use normalize age. In the update modify parameter, use okay, and then in the update here we do a lerp. So set this back in here and we do a lerp. Normalize age. Normalized loop age. What does that give us? One to 0. That's not the right one. Age. Yeah, there we go. This is interesting. I could see you could go along a long time. Zero. Wow, there's a lot to learn here. This is what I keep running into with Unreal. I'm almost wondering if I should stop here because this is going to start to become unproductive. Because there's just, well, let's see where this goes. I put a screenshot into Grok here, and I said what we need to do is, okay, how do I get to start the lerp at the initial value? So I can show you this. I put to ensure the lerp parameter starts at the initial value. You need to store the random value of the spawn, use it at the starting point of the lerp. In the spawn stack of your Niagara system under rock emitter upward mesh burst, you already set up a random value for use random for. This is good. To use this value as the starting point for the lerp, you need to store it as a particle attribute at a set parameter. Gotcha. Starting to understand this. Like going from this cold, I'm really starting to understand this. So in the particle spawn, we have to do a set parameter. And the parameter button, drag a parameter from the field. We're going to put a starting, new float parameter, starting temp. And we can put starting temp over here. Nope. Starting temp here. Nope. To add a parameter, use the add button. Dynamic. I get it. I totally get this. Okay, so what we do here is we have a starting temp and we change that to be a random range float from 0.5 to 1. And then when we do our update, we set this to be a lerp between starting temperature and 0. Scaled by the age. I can't tell if that's actually working. Let's change this from 0 to 1. It should be obvious then. Actually, you probably could get rid of this, delete. And they're definitely different from each other, but it's weird that they all kind of start the same. I think the difference is actually the age. I don't think this is working. Let's change this. Let's just change it to starting temperature. Let's get rid of this. Dynamic material parameters. Let's remove this. Okay. And the dynamic parameters will be starting temperature. There we go. Stack context. I wonder what that means. Starting temperature. Okay, so these I have random temperatures now. And let's try this again. Dynamic material parameters. We're going to do a lerp over the age. Oh, particle normalized age. This is it. That actually might have been the problem. And we're going to end up with 0, 1 to 0. And then this should be starting temperature up here. If we do this starting, totally understanding this, starting temperature. There we go, we got it. I don't know the difference of stack context and the other one, but starting temperature, let's see if it makes a difference. Yeah, okay, here we go. So they're coming off in random temperatures, but they all go to 0 at the end. I don't like that, but at least we're now in control of what we're doing. Okay, so the first thing we want to do is the starting temperature should be higher, 0.75 to 1 or something. I also want the age to be, well, as long as we're doing this, let's fix this emitter. Particle age. Let's figure that out. Emitter spawn. Whoa, thank you for the update. I have this need. Somebody's asking what I'm working on right now. I have this need for hot objects in the game, so I'm working on this effect that makes things look hot. And I'm trying to get this to work with a particle system. And when it goes into the game, I think it'll be more obvious to be where it belongs. But, I mean, we're working on atmosphere, basically. Okay. Knowing so little about this particle system. Oh, this is interesting. This is where it scales itself. Initialize particle. Okay. Oh, here we go. Lifetime min, lifetime max. Random lifetime. Okay, so let's. Don't want to do a hue shift. Don't want to have a color. Unset the color mode. It's 3 to 5 seconds. Five to 8 seconds. It's a long time. 5, let's go 4 to 5 seconds. Okay. This is the scale, random. Okay. Velocity in a cone. Okay. Minimum, maximum. I think we want more velocity. Actually, I want the cone to be bigger. 30 degrees. Let's make it like... Looks like popcorn. Velocity higher, 1,000 to 2,000. Okay. The rotating looks stupid. Let's, I don't like how they scale either. So let's change the scale, sprite scale, mesh uniform, scale, min, scale, max. Scale the mesh size. We're going to just start at full scale. Okay, let's look at the collision stuff. Restitution, too much. Less restitution. A little bit more. This is how rubbery the objects are when they bounce. Radius calculation, we're going to use the mesh. Friction blending. Simple friction, yeah, friction, high friction, 1. This rotation is control the roll on collision. It's not doing what it's supposed to do. I gotta get him to stop rolling around. No rotation. No, they're still rotating. Default. Random rotation. Whoa, whoa. Solve the forces and velocity. Speed limit, acceleration limit. Drag. Rotational drag. Here, let's put this into more rotational drag. God, they gotta stop spinning. And they all can't cool off at the same time. What are we at? 8:30 here. I'm wondering if this is still interesting. I could, so this is what you would do to author an effect, and I would probably sit here for hours. And also, you know, I just noticed the materials are not right on these. Am I using the wrong texture? Wait a second. I have to figure out how to do that. This is, yeah, this should be this one. Save that. Yeah, that's the right one. Oh my God, that rolling. I have to like get rid of that initial spawning burst. Initialize the particle. Random. Okay, add a velocity in a cone. Yeah. go back to Grok here and the meshes are rotating when they are on the ground. Can I either get them to stop rotating or roll appropriately like they would with real collision. In the emitter update, update mesh orientation. No. Yeah. Rotation rate. Okay, I could stop them when they end, set the rotation rate to do a realistic rotation with collision. Enable physics-based rotation. Okay, that's what we should do. Let's delete this. Solve forces and velocity. Do we have that? Yes, solve forces and velocity. Use mesh collision, which it is. Adjust the friction and restitution to make the increase the friction. Okay. Collision. Balance restitution, simple friction. Actually, let's turn off simple friction. Add angular velocity known into the add angular velocity. Huh. You could just spend forever doing this. Wow. This is such an interesting. So angular, ANGU, velocity, scale velocity. Nope. Mesh burst. Okay. I think this is getting old, so I think I'm gonna stop. I appreciate everybody coming by. I'm gonna work on this a little bit more and get this tuned up. It's gonna take several hours of tuning through these values, but I think we're like 80% of the way there. Like we got the effect, the heat effect in there, and we got the heat effect tied into this thing. So somebody's asking here, is there a option for the OG graphics or maybe a performance mode to make the game run better on low-end PCs? We don't have any plans right now to just put all the OG graphics in, although that kind of sounds like a good idea. And we're not ready to do thank you for the donation, by the way. And you kind of do performance stuff at the end of the game versus at this point. So Unreal Engine lets us have fallbacks for things, and we'll definitely plug those in, especially for the console releases. Somebody's asking about Game Pass's Monopoly. I don't really know much about what the developers get for Game Pass, so it's hard for me to comment on that. All the stories I've heard so far is about systems like that the developers in the systems actually do pretty well, but it's all just like hearsay. Somebody's asking, will an RTX 4070 be able to run this? Yeah, I'm running this on an RTX 4060 right now. So that would be a better video card than I have in my computer right now. Happy to answer any more questions here over the next couple minutes, and then I will totally take off. All right, this is frozen, so I'm assuming now people are gonna say that we have a low frame rate, which is what happens when I scroll away from the window to answer questions. Doesn't look like anybody has any more questions. So I appreciate everybody coming by, and we will do this again next time. Thank you.